everyone, welcome to BigDataChamps, and this is our session number 3. And in this session, we will be learning about the data storage. Basically, that we will be requiring while building a end-to-end data pipeline. So basically, you must have heard about like ETL, ELT, these terms. So what is ELT? What is ETL? That we will be I'll try to give you an overview, and after that we will be moving ahead, and we will be discussing about the different type of storage, because this ETL and ELT, these things are like require so that you can understand those storage and why those storage are used in a particular kind of process like in ETL or ELT. So before moving to the different type of storage, first let's cover what are these ELT and ETL things are. So ETL as, so what is the full form? Extract, then transform, and then load. So basically load. And another thing is ELT. What is ELT means? Similar thing. Extract, load, and then transform. You can, okay. So let's discuss what is these terms basically. So ETL or ELT is nothing but a process of combining the data from like different data sources and basically loading that data into our target data storages like after doing the transformation and doing the processing on top of the data. So basically you will be having some data sources like databases, some APIs, Kappa topic. So that is your data sources, and you will be extracting that data, and you will be doing some transformation, that is the transform part. And then after doing the transformation, you will be loading that data to the basically your target data storage. So this is ETL, and the another thing is ELT. So in the first thing, what we were doing, as soon as we extracted the data, we are doing the transformation, and like on the fly we have to do the transformation. There is nothing storage, there is nothing in between transform and extract where we are like keeping our data. So there is nothing here, nothing. What we are doing, we have extracted the data, okay, using some tool or something, and basically we have transformed it on the way only. We didn't we will not be keeping it somewhere, like storing it or persisting it somewhere. We have extracted the data. We are doing the transformation on the fly, and after transformation, whatever will the transform data, we will be loading that to the some data storage again some data storage. Okay, so this is the ETL. And if I show you what is ELT, what we are doing, so we have some data storage, some data sources. So we have like some not here, let me take this. Let's say we have some data sources, okay, and from data sources we extracted the data using some ingestion tool. Using some ingestion tool, we extracted the data, ingestion tool, and then we loaded that data that basically we extracted from the data source as it is to some data storage. Okay, we loaded the data as it is, like we haven't make any changes like to the that data, and we load it as it is to the some data storage. And after that we will be further reading the data from this data storage, and we will be doing some transformation. Let's say using Spark, you will be doing some transformation, and after doing the transformation, you will again load it to, let's say, some data storage. Okay, so here what is happening, after doing the extraction part, we are loading that data as it is to some data storage, and then we will be reading the data from this storage and doing the transformation and loading into another data storage, so that further analysis like dashboard thing can be done. So basically what we have changed here is we basically bring this L like load part after the extract. We are loading the data uh, uh, directly from the data sources as it is to some data storage, and then we are doing the transformation. But in ETL we were doing the transformation on the fly. We were doing the transformation on the fly, and then whatever will be the transform data, that we are loading and persisting basically. So in the extract and transformation between these two things, we do not have anything persistent, data storage where we'll be keeping some data. So it is on the fly thing that we are doing. If your transformation job fails, then it like whatever will be the data, then like you have read from the data storage, from the data sources, you have to like redo it that again. Basically, you have to read that whole data again from the data sources, and there might be like multiple data sources you are reading the data. Okay, so let me show you some diagrams that I have created. So this is ETL. So what we have different data sources. Okay, and from these different data sources we are basically reading the data. Okay, using let's say Spark only, we are reading the data, and on the fly we are doing some transformation using Spark, and whatever will be the transformed data, we will be like directly writing to the some data storage that is nothing but the data warehouse. So in data warehouse we will be having our transform data, and once we have our transform data in data warehouse, so we will be further using like Power BI or Tableau to basically build the dashboard on top of this transform data or clean data, validated data, whatever we have in the data warehouse. For data warehouse we are using Hive. I'm just like giving an example of the open source tool. In the next session I'll be giving you an high level overview what are the different services are available in different kind, like different cloud providers, and there I'll be like giving an example how what kind of services that we can use instead of Spark, instead of Hive. Okay, for now I just considering the open source thing. So this is how ETL is doing. So we are consider like what we are doing, we are reading the data, and on the fly we are doing the transformation. There is nothing in between that. And after doing the transformation we will be loading the data to the data warehouse. Okay, so we have the raw data here, data sources, and then finally we have the transformed data. There is nothing in between that. We just have the transform our processing engine. And after doing once we have the transform data, we are building the Power BI like dashboards using the Power BI or Tableau. And what is ELT? So in ELT we have, let's say this is the data source, and let me just take it so that you can compare them. So in ELT what we have what we are doing, we are basically reading the data from the data sources using some ingestion tool. We are loading the data some data storage, and that is data lake. So we are ingesting the data from the data sources to the data lake. So we what we did basically, we are just loading the data from the data sources as it is to the data lake. We haven't done any changes in between. Scoop is just taking the data from here and moving it to the data lake. Okay, once we have the data in the data lake, now what we can do, we will read the data from this data lake using Spark, and we will be doing some transformations and validations, and we will be loading the data to the data warehouse. And then what we will be doing, we will be like creating the dashboards on top of the transform data. So now you will say, okay, but what is the difference? Like, what is the advantage and disadvantage of both? Because at the end, we are able to generate the dashboarding, like dashboards and reports. So what is the difference? So difference is, suppose, I'll tell you. So what is the difference? I would say drawbacks of ETL. What are the drawbacks of ETL and why we should use ELT? So basically. So once you basically have your data sources, you have basically all the data in your data sources, and these data sources will not be in your environment. These are the nothing like these are like separate from your data pipelines environment, like where your data pipeline like have been created, or you will be creating your data pipeline, that these environment will be separate, and these data sources will be like present on some other different locations, like or I would say, some other environments, or these like databases will be present somewhere else. APIs like have like created by the backend developers, that will be like somewhere else. The SFTP server will be present somewhere else. Kafka topic. These are like these things are like present in some different location, or I would say different environments. Okay, but what you are doing, we are reading the data from all the data sources. You are doing some processing, and then you directly putting the data to the data warehouse. So what you have basically, you do not, if you want to do some data analysis by yourself, like you want to go through your data, you want to do some analysis, you want to understand the data. So you do not have that choice here, because your data is present here. If you want to do some analysis, you have to connect to this database and do some analysis there. You do not have these data sources in your environment. So that is the drawback, first drawback. You don't have you know mm, flex flexibility for doing data analysis. So you do not have much flexibility of doing analysis on data, to try to understand the data, what kind of data is there. And if you do not have that idea about your data, and so how you will be like very confident about the transformations that you will be doing. So because if you want to apply the transformation, you should have a good like clear understanding about the transformation. And it is just a starting of the project. You do not know what kind of transformation that will be there, like changes in the transformation in the upcoming phases of the project. And you also don't have much clarity about the data. So it is kind of drawback only, because you do not have such clarity, and it is compulsory to do the transformation. That's why this is the drawback. So it is compulsory to basically do the transformations, and even you do not have like much understanding of your data, and like what you will get in like upcoming phases of the project, you do not have that, and you have to basically compulsory. It is compulsory to do the transformation in ETL if you are following the ETL process. So it is compulsory to do the transformations uh, before loading the data to data storage. So this is the drawback, and that's why we prefer doing following ELT: extract, load, and then transform. So in ELT, what will happen? You are basically loading the data using some ingestion tool in your data lake. Now that you have all the data in your data lake, you have all control of data in your data lake. You can easily like connect to this data lake and go through all the data and do analysis of all the data. And you now have much understanding, and if you have more understanding about your data, you can easily transform, put up like the transformations, etc. Okay, so here it is not necessary to do the transformation while loading. You have once first you have to load the data and then do the transformation. Now you have the access, you have the data in your environment, and then you have to basically do you will be applying the transformation on top of your data, and then loading the transformed data to data warehouse, and on top of that you will be building some reporting and dashboarding things. So this is why should we consider. Okay, you have more flexibility, because now the data is there in your environment, and you can easily basically like analyze it and doing the transformation on top of it. Okay, so this is why ELT is preferred. But the difference, if you can see here, one component we have added, data lake. If you see, it was not there in ETL. So it is like, you can say, additional cost or complexity increasing in the process of data pipeline, but it is what it is, and it basically give you more flexibility. If you will, like, in the upcoming sessions, I will be explaining you how we can basically replace the data lake and data warehouse with the data lake house that is there in the Databricks. So we will not be needing the data lake and data warehouse separately. We will be just having the data lake house, and that will be it. And so for now, I just tried to give you what is ETL and what is ELT. Hope you got some idea. Just high level idea will be sufficient. Now what we will do, we will discuss what are different kind of these storage, what are their significance, what are their properties, why should we use data lake here, why didn't we use the data warehouse here, why didn't we use the database here. So we should have used so that will be the question in your mind. Okay, so now I'll explain why what are these like different data storage are there. Okay, and we'll cover everything. Okay, so that you will get an idea. Okay, this is why we use data warehouse here. Okay, this is why we have used data lake here. This is why we have used the data warehouse here. Okay, now I'll let's go with the different type of data storage. So let's start with the database. So what is database? Why should we use database? Where should we use database? Okay, let me answer all of these questions. Okay, so database is, let me first give you an example. So suppose you have an e-commerce website, and like there are multiple customers that are placing multiple orders, let's say. And they basically, what you expect when you place an order on your website, on even on like Amazon or Flipkart, you want that order to be accept or placed like if instantly, as soon as you play like press the place order button. So you do not want to wait for, let's say, 5 or 10 minutes to get a confirmation of on your order if it is placed or not. You want that order to be placed instantly. So that's the case when there are multiple transaction happening, and those transactions needs to be processed concurrently and simultaneously on a system. In those scenario, we need database. It supports day to day, supports your day-to-day operations and can process multiple transactions concurrently. It can process multiple transactions concurrently. And basically what it does, it can do very fast write, read, and updates. It can do very fast. Basically, whenever someone is placing an order, doing some transactions, so those records are those records has to be created in your database table. And suppose someone has updated their information, that thing has to be happened very instantly in the database, in the table and in your database. So in their database support these things. It can do reads, writes, and updates very instantly. That's why we need database in those scenarios. So we also got the idea. We also get the idea about the applications where we will be needing the database. So where will we be needing in the banking also. In the banking you will need, because there are multiple customers doing transfers of fund from an account to a different account. So that those transfers of the money has to happen very instantly. If the customer don't want to wait for the money to be transferred, so that transfer has to happen very instantly. So banking ho gaya. Then we have e-commerce. So this kind of we also got this kind of application where we will need database. So what the other thing, the types also. Let's say types. So we have types. First is SQL RDBMS databases, SQL database, RDBMS, RDBMS, relational database management system, you can say. It is also. Then we have NoSQL databases. So basically, SQL database store the structured data. Structured data. Basically, that is nothing but a table form, and that has row and columns that rows and columns. And the NoSQL database, it store a kind of unstructured data like JSON, documents, and the example would be here. Let's say Postgres we have MySQL database we have. In NoSQL we have MongoDB, then we have Cassandra DB, etc. Okay, and open source we can have HBase, etc. So your AWS kind of database support like store the table form structured data that is in the table form, and uh, your NoSQL database support unstructured data like documents we have, like say JSON data, etc. So this we have XML. So this kind of data format it can store. And the one more thing is, like, the SQL databases are can be scaled vertically. What do I mean by vertically? Like, you can just add more resources to a particular system only. You cannot have multiple systems to support scalability. That I have covered in the session 2, I think. Yeah, I have covered that in depth. And I also showed you the diagram. I explained these concept with the diagram, so you can refer to the session 2. And NoSQL support, what kind of scalability support? It support horizontally. It can be scaled horizontally. It can be scaled horizontally. The next thing is basically the kind of workload it support. So it just support the basically day-to-day transactions only. Day-to-day transactions. Day-to-day transactions. It is not meant to for basically analytical. It is not meant for analytical workloads. It just it has, like, it support only the transactions transactional operations that I have just explained. What kind of transactional operations it support, like in banking and e-commerce. It is not meant for the analytical workload means executing complex queries. It is not meant for doing this stuff. It is not, because what will happen, like, there will be multiple customers that are like placing in the orders, and you do not want bad user experience. You want their transactions to be processed very efficiently, and if you do that analytical workload, if you execute the complex queries, then these operations will get affected. And basically the other operation, whatever are being going on the database, those operations will get affected, and your user experience will go in the bad direction. So that's why we should not do this thing. We have different data storage and different data systems to basically cater these scenarios, these use cases for the analytical workloads. We have different data storages and system. We will explore that in the in this session only. And then basically it supports OLTP. What does OLTP mean? It is online transactional processing. It is online transactional processing. What do I mean by that? It is a type of processing in which we process multiple transaction concurrently, that I have explained, like and that's what the database meant for. So it is nothing but a kind of processing that our database is supporting. So this kind of supporting also is known as OLTP. Okay, so that I have already covered. The next thing is how much data it can store. How much data it can store. It can store only recent data. It is not meant to store the historical data. We have the different data storage that will store historical data, but databases are meant to store only the recent data. So the next thing is the cost. Cost is high. Cost is high compared to the other data storage we have, and that I'll cover in this session only. So it support it support schema on write. It basically means when you write the data in your database, that time only it will be validated with the schema that you have specified. So suppose you want to create a table, let's say table 1. So what you did, you create a table, create table 1, let's say, and you specified some column 1 and its data type, let's say D type. Then you specified, let's say, column 2 and its data type D type. And so similarly you did this thing. So this is nothing but a schema. This is nothing but what you are doing, you are specifying a schema. This is the schema, this is the table name, this is the schema, like these are the column name, data type, column name, data type. This is the schema that you are defining for this column, for this table, sorry. And this will be stored in database as metadata. This will be stored as a metadata. So now what you will do, you will you will do some insert into, let's say, your table 1, and you will specify the values, let's say value for column 1, value for column 2, let's say, etc. So now what will happen, this will not directly go to the table, so what will happen, this table, this data first validated with the schema you defined above. So the schema you have defined here, this data that you want to insert, this will be validated first with this schema. It will check what all values you are passing. It should match the total number of columns here, and the total number of values should match, and the data type you are basically providing, it should match the data type you have defined in your schema. Then only it will allow to insert into the table. So what we are saying, it support schema on write. So while writing the data, it is validating your data with the schema you have defined, and then it is allowing to insert. So that's why we say it is schema on write. Basically, if you want to say validate schema on writing the, or let's say inserting the records. So it validate the schema at the time you are inserting or writing the records. At the time you are basically doing the insert and writes. So it is doing that. That's what the schema on write means. It is a very important concept, and you should keep this in mind. It will be asked in the interview very frequently. So applications, what are applications? We have covered already. Application I do not have to write again. We have the applications covered, example. So this is nothing but what it is. I've covered database. Let's move to the data warehouse. So let's move to the data warehouse. So what is data warehouse? Why should we use data warehouse? Let me give you an example again, because with the help of example, we do remember the things for a long time. So let's suppose you have your validated data. Okay, somewhere like in the database, you have some data that basically you extracted as a transactions from the users. You have that in your database. Database have these transac transactions, and okay, so you want to do some analysis on top of it. You want to do some analysis on top of it. Analysis means, let's suppose you have, let's say, different type of tables. Let's say you have customers tables, you have orders, you have order items, because a order can have multiple order items. And let's say you have product products table, in which all the products are there that are that are available on the let's say e-commerce website. So now what is your analysis? You want to do analysis like you want to calculate the uh, the amount spent by each customer for each product category, and on, let's say, quarterly basis or monthly basis. So I'm just trying to generate an example. I haven't it is just a random example I've generated. So you are trying to basically calculate this thing, and to get to get this amount, to get this thing, you need all these tables. You need the data from all these tables, and you will be applying the joins. So let's suppose you want to do analysis on, let's say, like last 10 years data, so this joining the tables required a high lot of computation power. And if you do this thing in your database, the other operations that are being going on your database will suffer. It is not meant for analysis, that I have already covered. So we need, and again, your database will not be having a lot of data. It will be having only recent data. So we will need something here where we will be storing our data, and this thing should support storing a lot historical data, and it also support complex computation. And so basically what this thing support, we need some data storage here, some kind of data storage here, which support which can hold basically historical data plus high computational power. Basically, this storage system can hold the historical data, as well as uh, it can process this whole lot of data very instantly, and so for that it should have very high computational power. Okay. So, and what is this what kind of data storage it is? Like example, we have the data warehouse which support this feature, data warehouse. Data warehouse is meant for doing this stuff, okay. So why basically we have data warehouse? Why? Let me write here. Basically, it supports the analytical workloads and can execute the complex queries efficiently. It can store a whole lot of like data very efficiently. So that's why it is meant for basically to do this stuff. It is meant for to do this stuff. The data warehouse is again a storage plus compute. It has both the thing. Sorry, storage plus compute. It has both the thing. It has both the thing. It can store the data. It has that part also. It has the compute power also. Basically, okay. Basically, what I want to say, just if you understand, want to understand at a low level, it has hard disk, hard disk. It also have compute. It also has compute means it has RAM also. It has CPU cores also. So this is the compute part and this is the storage part. And data warehouse has both the things. So the next thing I would say is the type of data store again. Type of data it can store. It can store only structured data. Structured data in the basically in the table format that will have rows and columns. So this is the data type part. Workload, it will support, it can process the high like analytical workload that I've already covered. So it is meant to it is meant for complex analytical workloads which was not possible on database. So it is meant for doing these things. It can process a huge amount of data because this is optimized for that. It is optimized for doing this stuff. Okay. The next thing is the cost. It is again costly but less than database. It is costly but less than database. Again, the next thing, it support schema on write. It supports schema on write. What do I mean by schema on write? I have already explained here. Schema on write. And the next thing is it supports ETL process. It supports ETL process, or I would say it follows ETL process also. What do I mean by that? I showed you an example here. So if you see in the ETL process, we are using data warehouse. So as soon as we are like extracting the data on the fly, we are doing some transformation and then we have to load the data in the data warehouse. So here so basically we have the transform data and we want to do some analysis. So, and for analysis, what is the tool? Data warehouse. That data warehouse is the thing that supports the analysis. It can execute the whole lot of like complex queries. So that's why we are using data warehouse here, and that's why we are saying the ETL like data warehouse. Support ETL or follow ETL process. You have the data warehouse here. You don't have the database here because database will not be able to execute the complex SQL queries. Data warehouse is here because it can do these things and it can store a whole lot of data because data will be keep coming and you will keep doing the transformation and keep storing in the data warehouse. So it should store a lot of data, and yes, data warehouse can do that, and it can do the analysis and it can execute a complex SQL queries on top of your that huge amount of data. It is optimized for that. That's why we are using data warehouse here. We are not using anything here. So the one more thing is in the data warehouse is the data was supporting like OLTP, data warehouse support OLAP. What does it mean? Online analytical processing. So it support online analytical processing. So it is again a kind of, it is nothing but a kind of processing in which we process a large amount of data, in which we process a large amount of data. But in online transaction processing, what we were doing the processing of small chunk of data. Like I would say, we were doing the processing at a transaction level. We are our focus was on each transaction that has to be executed. We were not waiting for a whole lot of transactions or orders to be placed first, and then we will be doing the their confirmation, and if the order has can be placed or not. What we were doing, instantly we were checking a particular order that has came from the customer, and if it can be if it can be placed or not, and instantly we are basically taking the actions to those respective transactions. We were doing the uh, processing at a transaction level. Here our focus was more on the transactions level, but in the OLAP our focus here is on basically processing, to process huge amount of data. So our focus is on processing huge amount of data, and for that what we need a system which can store a whole lot of data and which has the high computation power. And this is what the data warehouse support. This is what the data warehouse has. It can store a whole lot amount of data, and it can compute a whole lot amount data, and it has that capability. It has that high computation power. It has that, and that's why it support OLAP. If you need example, like what an OLAP, if you if you can get an example of OLAP. So if in the beginning only I gave you this example to calculate these things. So what you are doing, you are taking a whole lot of amount data, and then you are processing it. And for that, and this kind of processing only we are referring as a OLAP, online analytical processing. This is the example you can take. Okay, for this kind of processing, what kind of scenario or use case that will come under this kind of processing. So this is that use case, and our data warehouse support this. Okay, so let's discuss the third one, the data lake. So what is data lake? It is just a storage. It is just a storage. It doesn't have any compute thing. So it can store a huge amount of data, and it is like highly scalable, whatever. Okay, it is highly scalable. So basically, like it doesn't provide any compute power. It can just store the data, and basically it can store any kind of data. It can store any kind of data. Type of data, if I say type of data, it can store uh, structured, semi-structured, and unstructured data. It can store any. So initial what you will be having is, so if I show you an example, so so you will be having like different kind of data sources, and these different data sources will be having the data in the different data types. Let's say the database will be having the data in the table format, that is structured data. APIs will be having, let's say, JSON or XML kind of thing, that is like some semi-structured and structured data. SFTP will be having, let's say, again semi-structured data, some JSON file, CSV files. Kafka topic again have, let's say, JSON data. So the type of data that are available on these data sources are different, and you need something to store these kind of diverse data types, basically. So data lake is there to basically store these different type of data. Okay, the data with the different data types, basically. You will keep reading the data from your data sources and keep loading the data into your data lake. So it will able to, basically it can store the huge amount of data. And what we have learned in the ELT part is basically we are using the data lake, and that's why, and that's the reason we are using the data lake here. It can store the data from multiple data sources that have like data in the multiple data types. So data lake, that's why we have used data lake here. It is able to store the data of the different data types, and it can store a huge amount of data. So you will keep reading the data and keep, inserting the data in your data lake. That's why we have used data lake here. Okay, so it is basically storing the different kind of data types. So the next is it support OLAP. What I mean, online and sorry, it support online analytical processing. What I mean by that, type of processing where huge amount of data is processed. So it basically process whole lot amount of data in a single process execution only, one time, I would say. It support, it does not do that. Basically it just have a storage. We will need some kind of thing, some kind of tool that is basically helping us to process this thing, process a huge lot amount of data that is stored in the data lake. So what is that? For example, so let's say we have Hive, which is a data warehousing tool. So what we can do, we can no link with, let's say, SDFS, data lake, SDFS, which is a data lake. So what you have did, you have linked it with SDFS, and SDFS has a lot of data. Now what you can do, you can write the queries in Hive, and you can read the data that is stored in basically SDFS. So indirectly it is supporting OLAP. Basically we are using Hive to do the analysis on top of the data that is stored in the SDFS. It is SDFS, or the data lake itself does not do any processing. It needs some kind of data warehousing tool that can read this huge amount of data and can do the processing part. So it is supporting the OLAP, but we need some additional tool that will help us to do that. It has the high amount, like a lot of amount of data, and Hive is basically doing the analysis, basically doing the execution part. It is Hive is providing what is providing? It is providing compute, and SDFS has storage. So we need two things to do the processing analytical workload. We need two things: huge compute power and storage. Compute power basically we'll get from the Hive, and storage thing we will get from the SDFS, and that's why we will be able to do the LAP processing. Okay, that is the cost. Now the thing is the cost. It is low cost thing. It is low cost when it is compared to the data storage, database and data warehouse. It is uh, less costly, very less costly. It is like in the data lake we are just using the hard disk. That is a commodity thing these days, which is like available at a very lower price. That's why the cost of the data lake storage is very less. We are using hard disk, that is very cheapest. Okay, so the another thing is it support schema on read. So basically what does it mean? It basically validate the schema at the time of reading the I would say. So it will validate the data at the time of reading only. It will not do like while storing the data, because SDFS will have the data at the first place. We will be directly storing the data, extracting the data from multiple data sources. extracting the data from multiple data sources and ingesting in the data lake. At this time, at when we will be like loading the data in the data lake, that time we are not doing any, we are not specifying any schema. We are just taking the data, raw data, and storing the data lake. So data lake already has some data. Now what we are doing, we are using Hive, or some other data warehousing tool to read this data that is already present. So that's why like we are saying schema on read. Now that if the data is already present, what time we can basically apply the schema? At the read time, because at the time of writing we haven't applied anything. We are just took the data and stored it the data lake. So at the time of reading, we will be applying some schema on top of the data that is already present in the data lake. That's why we say it support schema on read. And for example, let's say I have something for you. For example, this is the diagram. So this is the diagram. Let's suppose we are using Hive and we have basically linked it with the SDFS. So we created some table. So creating the table doesn't directly like what we are saying, like we have created a schema in the as a metadata. The schema will be created and the location. So let's suppose while creating the table, we have specified the location. Okay, like this is the location our data is stored. So while creating the data, this table, Hive will not do any validation. It will just create the table as it is. It will not do anything to validate if this particular file is even exist in the data lake or not. It will not do anything. Okay, it will just create the table, whatever the command we are saying. It will just execute that. It will register the schema and the location associated to that particular schema. It will just store that as a metadata. It will not do anything. And when we will execute the select query, select star from customers, what it will do, it will first go to this metadata. It will check, okay, this is the schema and what is the location. It will say, okay, this is the location. So it will go to this location. It will take it will take this data and it will like take this schema also, and it will take this schema. It will go to this file. It will check, okay, the schema you have given, it will, if it is matching with this file fields or not, what are the fields, what are the data types that are there in this file. It will validate this schema with this file and then it will return the result to us. And if the schema that we have specified at the time of creating the table, if it is not matched with the this fields that are present in the CSV file, if these two things doesn't match, then while reading the data we will get some error. So we will get the error at the time of reading only, because at the time of writing Hive is not doing anything for the validation. It will just creating the metadata and storing it. At the time of reading, it will taking this metadata, going to this location, it will imposing that schema on top of this file, and if the schema matches with the data fields that are present in the CSV file, if these matches, then only we will get some result. If these things doesn't match, the schema and the fields inside the customer CSV file, we will get an error. We will get some error in return. So this is the basically importance, like I have explained the schema on read in very detail. So you will not get these kind of explanation anywhere, and that too in layman term and on YouTube. I'm going very deep in the things, and that's why the lectures, or I would say the sessions are are quite big, lengthy, and you are getting information. So let's finish. So we have covered data warehouse, database, and data lake. We have also covered the ETL, ELT part, and one more thing, I think, yeah, I forgot. So the last thing is it support ELT. And we have already, I have showed you that in ELT we use data lake, because we needed something that can store any kind of data type, data with any kind of data type. And data lake is basically meant for that. It can store data with any data type, and that's why we are using data lake in ELT here at the first place. In just after reading the data from the data sources, we are ingesting it directly into the data lake. That's why we are saying it support ELT. And now you know why we use data warehouse here, why we use data lake here, why we use data warehouse here. You know these things. I have already explained the. I hope you guys have understood most of the things. And if you have any questions, any doubt, you can please comment in the comment section, and we'll try to revert back to you for sure. So that's it for this session, and we will meet in the next session.